Let's draw some scales in. Well, we've got our axes. Now let's plot onto here just a function that we can. Welcome to the PiFactory series of lessons on how to find the derivative of an inverse. So let's start to look at this word inverse for a start. Inverse usually means, we take it to mean opposite, and sometimes we think that it undoes the original function. So these are two words we use with inverse. Let's just have a quick recap of what we mean a little bit in more detail. Here we've got a function f, and its graph will be represented by coordinates x and y. The inverse, this is the notation, the way we write this stuff, the notation. It's not an exponent, it's not an exponent to the -1, it's just notation, and we say inverse f. And the graph of inverse f is simply going to have coordinates y, x. So we swap the y's over and we swap the x's over. And the whole point of an inverse is that we swap inputs and outputs, domain and range. That's what we think of as an inverse. So looking at our function here, which we can label f, let's say that's f. Let's now try and plot inverse f for this function. Well, 7, 10, we're just going to plot a point 10, 7, 10, 10, 7. Here, 9, 5, 9, we're going to plot 9, 5, 9, come up to there. The inverse is going to be 9, 5, 3, 7, 7, 3. And then we can just plot a few more. 4.5, 4.52. That looks to be 1, 3, so it's going to be 3. Nice curve through those points. So this we can label, this is our function inverse f. Now we can also see that there is some symmetry here, and we may recall that if we draw a line through the middle here, line y equals x, let's just see where that's going to come. Y equals x, and just draw that line lightly through there. That's the line y equals x, y equals x. We find that there is symmetry between our function black f and its inverse in red, inverse f here. And if we just take a look at these points here, well, that distance and that distance are the same. Just mark those using some geometric marks. And that looks to me to be a right angle. So we have symmetry between F in black, inverse F in. Okay, let's just have a look at one way that these inverses work. Let's say we've got an input here. So we're inputting to this point. So here we've got an input. We come up to here, and for this input, which is 7, we come out here, and we get an output of 3. And we can say that this is inverse F of, let's say, X. And I think we're going to call that an X input. It happens to be 7. The input is 7 and the output is 3. But the input is X, so the output is inverse of X. Inverse F of X, sorry. So now let's just take this number round, and make it an input here. And this input, 3, or F inverse X, is we're going to take this all the way up to F. Here's F. Let's put a little box in there. And out comes 7, which, hang on, was what we put in the first place, X. So that is one way that inverses work. We come in here with an input, we bounce off of the inverse, come round, we make the output of the inverse the input, and we go back up to our original function f, out we come 7 and 7. Similarly, if we've gone in here, 3, output to 7, come round here to 7, input, output 3. So that's how inverse functions undo them.